where f of x equals log base 2 of x, evaluate this for x equals 8, 64, and 1/5/12. Should do that. It's basically the same thing as we were doing, isn't it? Because this is just saying plug these numbers in for the x. So the first one, x is 8. I mean, we could put it in x is 8, so I'm evaluating f of 8. What does it mean? It's log base 2 of 8. Just plugging in x to be 8. Well, it equals something. Anybody got it? What would that one be? Be 3, yeah. 3? Why? 2 to what power gives me 8, right? 2 to the third gives me. Power is 3. So, all right. Then it wants me to do f of 64. X is 64, so that'd be log base 2 of 64, which I didn't get to over there on my powers. What would that one be? 6. 2 to the 6 gives me 64. Yeah, so this would be what this one equals. Okay? And last but not least, f of 1/5/12. Can we do that one? Or is that one not a nice number? Can't just say it's not a nice number on these. We'll do the not so nice numbers later, but yeah, this one's a pretty nice number. So we're looking for 2 to what power gives me 1/5/12. Well, we went to 6 here so far. 2 to the 7th gives me, what does 2 to the 7th give me? 2 to the 7th. Somebody tell me. Help me out. I think I know it. 128. Okay. 2 to the 7th is 128. Yeah, if I don't know what this number is power of 2 wise, just go through your powers of 2. 2 to the 7th, 2 to the 8th, 2 to the 9th. Till I get one. These all should be nice powers of whatever base it is we're talking about. 2 to the 8th is 2 to the 56, so we've got to go 2 to the 9th. 2 to the 9th gives me 5/12. Not quite what I need, though. I need 1/5/12 to the -9. So what's the value of this logarithm? -9. Everybody okay? All right. Now there are a couple of special logarithms. Sorry about those. Logarithms that are utilized, I guess you might say, in applications more than others. One way to put it. And so they're given their own special notation. First one's called the common logarithm. Logarithms can have any base, positive, besides 1. Logarithms can have any positive number base. Well, the common logarithm is specifically the logarithm base 10. And it's denoted just as the log of a number, x. Now, what's special about that? Why is that special? LOG. Notice what's missing here. Yeah, there's not a number base there, is there? So if we don't see a base in our logarithm notation, the base is base 10. It's the common logarithm, okay? So no base showing on LOG, but it's understood to be 10. Okay, understood to be base 10. So if I have log of 1 million equals 6, and it asks me to convert that to exponential form, well, exponential form, you just start with a base. Well, there's not a base. I can just choose any base? No. With LOG, it's base 10. So this is 10 to the 6 equals 1 million. That's what we're saying. This base is 10. Okay? Number 2, special logarithm is the natural logarithm. We spoke a little bit about the natural base last time, and what did we say the natural base was? Did I mention that word, natural? Oh, I did? Oh, never mind then. The natural logarithm is the logarithm base e. Common logarithm base is 10. Natural logarithm is base e. And the natural logarithm is denoted ln of x. Again, there's not a base there that is shown, but with this notation, ln, hence natural logarithm, probably the reason for that, there's no base showing on this one, but it's understood to be base e when I see the ln. The understood base is e. We see ln, it is understood base e. And so if I have ln of ln of 25 equals 3.218875825. That's not the end of it. That's what my calculator shows. What's that in exponential form? Well, again, there's not a base showing, but in exponential form, this is base e. Or it is base e, and then so in exponential form, I put e to 3.218875825. That equals 25. All right. Well, suffice it to say then that ln's of numbers are not going to be nice whole integer numbers. The good news is the calculator will do these for us. We can most calculators will evaluate common logarithms and natural logarithms on the calculator. Scientific calculators. Most of them have both. Yeah, my little TI-30 here has both the common logarithm and natural logarithm. So we don't have the problem. A while ago we said natural, the log base 2 of 30. I don't know what that is, but the common logarithm of 45, that's not going to be a nice number, is it? That's 10 to what power is 45? 10 squared is 100. 10 to the first is 1. 10 to the squared is 100. So I've skipped, so to speak, nice powers. There's not a nice power of 10 gives me 45, but the calculator will do that for me. If I can figure out how to work it. All right, 45. Yeah, the LOG button should be on your calculator there. It's 1.532. ... Okay, how many ever you would like. So we can evaluate common logarithms. We can evaluate natural logarithms, which is what I did over here. What is the, somebody tell me the natural logarithm of 750? Anybody got natural log? 6.62. Yeah, so it's easy enough to get those. Okay.